you ever left a glass of water in the freezer to cool down for a nice cold drink and forgotten about it? What do I do? Do I put this in the oven to warm up, or do I leave it out to warm up naturally? Might be different if it's in the swimming pool in the middle of winter. Let's have a look.
In der Mitte am besten da.
Ja. Ich will nicht mal gucken, nicht dass das zu hart ist.
Nicht drauf?
Ja.
Mother, the fucking world, and my new band is called Skill.
We're going to catch up with our German friend a little bit later, but in the meantime we're going to consider specific heat capacity. Now this is the amount of energy that's needed to raise the temperature of something. We're going to calculate the amount of energy that's required to work out what the substance is. So the amount of energy that's required depends on if you've got a small glass or a large swimming pool, and also if it's a different material. It might not be water. Now copper, as we know, is a good conductor of heat, so that may not take as much energy to raise the temperature. The amount of energy that's required to raise the temperature is the mass in kilograms times the specific heat capacity times the temperature rise. For example, if we take the glass of water, we can assume that maybe there's about half a kilogram of water in there. The specific heat capacity of water is 4,200, and we want to raise the temperature to something that's drinkable, say 20 degrees. The amount of energy needed is going to be 4.2 kilojoules. Now compare that to the swimming pool. Now the swimming pool, we can assume that there's about 500,000 kilograms of water. That amount of energy is now 42 million kilojoules. Okay, now let's consider how we can actually work out what the substance is. Have a look at how that's done.
If I have a block of metal, but I don't know what this metal is, how do I find out what it's made of? I can find out by determining its specific heat capacity. Let's look at this equation. We know that energy transferred is equal to mass times specific heat capacity times the change in temperature. If this is the unknown, I need an experiment to find its mass and the energy transferred to change its temperature by this much. We can start by putting the metal block on a weighing scale. Its mass is 1 kilogram. And since there are 2 holes drilled into the block, I can insert an immersion heater into one of the holes and connect the immersion heater to a power supply. But how do I know how much energy is being transferred from the power supply through the immersion heater to the metal block? I need a joule meter. Let's connect it right in between the power supply and the immersion heater. So the immersion heater is going to heat up the metal block, but I still need a way of measuring the increase in temperature. There's another hole in the block, so I can insert a thermometer. Now insulate this with plenty of cotton wool. We're ready to start. Record the initial temperature, which is 23 degrees Celsius. Flip the power on, and when the temperature reaches 33 degrees Celsius, we are going to turn off the power supply. The final temperature is now 33 degrees Celsius, and the reading on the joule meter tells us the amount of energy that has been transferred. Let's do the math now. Rearranging this equation to make specific heat capacity the subject, we have specific heat capacity is equal to the energy transferred divided by the mass times the change in temperature. 3,850 joules divided by 1 kilogram and 10 degrees. We've worked out the specific heat capacity of this metal to be 385 joules per kilogram degrees Celsius. Let's compare this to my charts. That tells me the metal is copper.
Okay, let's get back to our German friend, see how he's getting on the swimming pool.
Mother world, and my new band is called Skill.